Have you ever wondered what happens beneath the soil? Down where the world is dark and damp, a magical process is taking place. This is the world of roots. They are the hidden half of a plant's life, working tirelessly to support what we see above. We often admire the beautiful flowers and the green leaves, but the roots are the true foundation. They are the anchors and the lifeline. Today, we are going to bring this hidden world into the light. We will explore this secret kingdom not in the dark earth, but in a simple, clear glass jar. This allows us to watch a plant's journey from the very beginning, day by day. Growing a plant in a jar is like having a small window into nature's secrets. It is a wonderful experiment that anyone can try at home. It does not require a large garden or special tools. All you need is a cutting from a plant, a glass jar, and some water. This simple setup becomes a stage for one of nature's most fundamental dramas, the growth of life itself. By placing a plant in a transparent container, we remove the mystery of the soil. We can observe every new root as it appears, watch it lengthen, and see how it behaves in its tiny glass world. This is a journey of discovery, a visual story of resilience and adaptation. For our exploration, we will follow a single plant cutting for 100 days. This is a significant amount of time in the life of a small plant. It is long enough to see remarkable changes and to understand the many challenges that roots face. We will witness their initial burst of life, their search for sustenance, and their struggle against the limitations of their environment. This is not just about growing a plant, it is about learning. We will learn what roots need to thrive, what happens when those needs are not met, and how incredibly persistent life can be, even in the most unusual of homes. It is a slow, quiet, yet utterly fascinating spectacle. So let us begin our journey. We will become observers, scientists in our own homes, watching the story of a plant unfold right before our eyes. This 100-day diary will reveal the quiet, determined power of roots. We will see how they navigate their world, how they drink, how they breathe, and how they fight to survive. The glass jar is our laboratory, and the plant is our teacher. The lessons we learn from this simple experiment can change the way we look at the green world around us forever. It shows us that even in a small, confined space, the force of life is a powerful and beautiful thing to behold. To understand our plant's journey, we must first understand what roots are and what they do. Roots are the plant's essential support system, performing several vital jobs. Their most obvious function is to anchor the plant firmly in place. Whether in soil or in water, they act like a ship's anchor, holding the plant steady against wind and other disturbances. Without strong roots, a plant would simply fall over. This stability is the first gift that roots give to the plant. It allows the leaves to reach up towards the sun, which is the source of their energy. The roots provide the strong base upon which everything else is built. But roots do much more than just hold on. They are also the plant's mouth and stomach, responsible for absorbing all the water and nutrients it needs to live. Tiny, almost invisible hairs on the surface of the main roots do most of this work. They reach out into their surroundings, pulling in water and dissolved minerals from the soil, or in our case, the water in the jar. These nutrients, like nitrogen and phosphorus, are the building blocks of life. They are transported from the roots up through the stem to the leaves, fueling the plant's growth. This constant supply of water and food is absolutely critical for the plant's survival and well-being. Roots also need to breathe. This might sound strange as we usually associate breathing with lungs and animals, but plant cells, just like animal cells, require oxygen to convert their food into energy. This process is called respiration. In soil, roots find oxygen in the small air pockets between the particles of dirt. In our glass jar, this becomes a major challenge. The roots must get their oxygen directly from the water or from the air just above the water's surface. If the water becomes stagnant and loses its dissolved oxygen, the roots can essentially suffocate. This is a hidden danger that we must watch for. Finally, roots have a sense of direction. They are guided by gravity, a phenomenon known as gravitropism. This is why roots naturally grow downwards, deeper into the earth, in search of stability and water. They are also guided by moisture, growing towards areas where water is more plentiful. In our jar, we will see this behavior in action. The roots will grow downwards, following the pull of gravity, and will spread out to explore their watery home. Understanding these fundamental needs, anchorage, water, nutrients, and air, is the key to helping our plant survive its 100-day journey in this very unusual glass house. The experiment begins with a simple act. We take a cutting from a healthy parent plant, perhaps a pothos or a spider plant, which are known to root well in water. We place the cut end into a clear glass jar filled with fresh, clean water. For the first few days, very little seems to happen. The cutting sits quietly, a lonely green stem in a still world of glass and water. It appears dormant, as if it is resting or waiting. But beneath the surface, a hidden biological clock has been set in motion. The plant is using its stored energy to heal the cut and prepare for a monumental task, growing a brand new root system from scratch. Around day 5 or 6, the first sign of life appears. It is a tiny, wondrous event. Small white bumps, almost like pimples, begin to form along the submerged part of the stem. These are the root primordia, the very first cells of the new roots, pushing their way out into the world. It is a moment of great promise. The plant has successfully switched from being a part of a larger organism to becoming an independent individual. These small bumps are a declaration of intent. They are the visible proof that the cutting has accepted its new challenge and is beginning the process of establishing its own foundation for life. By day 10, the transformation is undeniable. Those small white bumps have elongated into delicate, pure white tendrils. These are the first true roots, reaching out into the water. They are still short, perhaps only a centimeter long, but they are active and growing. They look fragile, almost like threads of cotton, but they are incredibly powerful. They have already started their primary job of absorbing water to send up to the leaves, keeping them hydrated and green. Watching this initial growth is a truly magical experience. It is like witnessing the dawn of a new life, a quiet but determined explosion of biological energy. During these first 10 days, the plant relies entirely on the resources stored within its stem and leaves, and the oxygen dissolved in the water. The water needs to be fresh to ensure it contains enough oxygen for the new, developing root cells to breathe. If the water were old or stagnant, this process might fail before it even truly begins. The purity of the white roots is a sign of health. There is no hint of decay or disease. The journey has started successfully. The plant has taken its first brave step towards independence, and its new roots are the symbol of its victory over the initial shock of being cut and placed in this new, watery home. As our plant enters its second week in the glass jar, the initial tentative growth gives way to a period of rapid expansion. The first few roots, which were so small and delicate just days ago, now begin to lengthen and thicken with surprising speed. It is as if they have found their footing and are now confidently exploring their new environment. More roots emerge from the stem, joining the first pioneers. The root system starts to look less like a few stray threads and more like a proper network. This is a critical time for the plant, as it invests a huge amount of energy into building this underground architecture. The more roots it can grow, the more water and nutrients it can absorb. By the end of the third week, the changes are dramatic. The roots are no longer just simple straight tendrils. They have started to branch out, creating secondary or lateral roots. These smaller roots grow out from the sides of the main ones, creating a complex web-like structure that increases the surface area for absorption. This branching is a sign that the plant is establishing itself properly. It is building a system that is not only efficient at finding water, but also strong enough to provide a stable anchor. The jar, which once seemed so empty, is now becoming visibly filled with a growing maze of white and pale yellow roots, a beautiful and intricate pattern of life. During this phase, the plant's needs begin to change. The initial supply of nutrients stored in the cutting is starting to run low. While water provides hydration, it typically contains very few of the minerals that a plant needs for long-term, healthy growth. The leaves might still look green, but the plant is essentially on a starvation diet. For now, the focus is purely on root production, as the plant instinctively knows that a bigger root system is its only hope for finding more food in the future. We, as observers, can see the roots growing, but we must also be aware of the invisible hunger that is beginning to set in. By day 28, at the end of the 4th week, the root system is well established. It is a beautiful, thriving network that fills a good portion of the lower half of the jar. The roots are healthy, firm, and show no signs of rot. The water has remained relatively clear, though we might have changed it once or twice to replenish the oxygen supply. The plant has successfully passed a major milestone. It has built a fully functional root system from nothing. However, new challenges are just around the corner. The very success of this growth will soon create problems within the limited confines of the glass jar. Around day 40, a significant event occurs in the life of our jar-bound plant. The longest and most adventurous roots finally reach the bottom and sides of the glass jar. They've basically run out of room to grow downwards. This is a moment that never happens in the wild, where roots can burrow deep into the earth. In the jar, though, they hit a hard, transparent barrier. Upon making contact, the root tips, which are the primary centers of growth, will change their behavior. Instead of stopping, they'll turn and begin to grow along the surface of the glass. This is the plant's remarkable ability to adapt to its physical limitations. As the roots continue to grow, they begin to circle the inside of the jar. This creates a pattern that is both beautiful and, honestly, a bit worrying. The roots start to form a dense, tangled mat against the glass walls. This condition is often called being root-bound. While the plant is still growing, the efficiency of the root system starts to decrease. The roots become crowded, competing with each other for the limited space and resources. They can no longer spread out freely to search for nutrients. This confinement is the first major stress that the glass jar imposes upon the plant, a direct consequence of its limited size. At this stage, another problem often begins to appear: light. In nature, roots grow in the complete darkness of the soil. They've evolved over millions of years to live without light. But constant exposure to light, as happens in a clear glass jar, can be stressful for them. Light encourages the growth of something else in the water: algae. You may start to notice a faint green tinge on the inside of the glass and on the roots themselves. These are tiny, single-celled organisms that thrive in water, light, and nutrients. They compete with the roots for oxygen and any available nutrients, and can make the water look murky. The roots themselves may also change color. Instead of being a healthy, bright white, some of the older roots might start to turn a yellowish brown. This is partly a natural aging process, but it can be accelerated by the stress of being crowded and exposed to light. The plant is still alive, and the leaves above may still look perfectly fine. But these are the first subtle signs that the ideal conditions are beginning to fade. The jar, which was once a perfect nursery, is now becoming a more challenging environment. The plant has reached the halfway point of its journey, and the struggle for long-term survival has truly begun. As we pass the 50-day mark, the challenges for our plant become more pronounced. The root system is now incredibly dense, a thick tangle that occupies a large volume of the jar. The initial beauty of the expanding network has been replaced by the sight of a crowded, competitive mass. The roots are so tightly packed that water circulation becomes difficult. Pockets of stagnant water can form within the root ball, where oxygen levels drop dangerously low. This lack of oxygen is a serious threat. Without it, the root cells cannot perform respiration, and they can begin to die and decay. This is the beginning of root rot. The first signs of root rot are subtle. A few roots, usually in the most crowded parts of the mass, may turn brown and become soft or mushy to the touch. A faint, unpleasant, swampy smell might begin to emanate from the water. This is caused by bacteria that thrive in low-oxygen environments, feeding on the dying root tissue. If this process is not stopped, it can spread throughout the entire root system, eventually killing the plant. At this stage, our intervention becomes critical. Changing the water more frequently, maybe every 2 or 3 days, can help to reintroduce oxygen and wash away some of the harmful bacteria. Nutrient deficiency also becomes a very visible problem around this time. Tap water alone cannot sustain a plant for this long. The leaves, which were once a vibrant green, may start to show signs of yellowing, a condition known as chlorosis. This often starts with the older, lower leaves. The yellowing might appear between the veins of the leaf, indicating a lack of specific minerals like magnesium or iron. The plant is now using up the last of its internal reserves and is showing clear signs of starvation. Its impressive root system has nothing to absorb from the plain water, and its overall health begins to decline as a result. To combat this, we can provide a lifeline. Adding a very small, diluted amount of liquid fertilizer to the water can replenish the missing nutrients. This is like giving a meal to a hungry person. The roots will quickly absorb these minerals, and if the deficiency is not too advanced, the plant can recover. The leaves may regain some of their green color, and new growth might even appear. However, this is a delicate balance. Too much fertilizer can be toxic. It can burn the delicate roots and make the situation even worse. Our role as caretakers has become much more active and crucial. By day 75, the ecosystem inside the jar has become much more complex. The green film of algae, which started as a faint tinge, is now a significant presence. It coats the inside of the jar and covers many of the roots, giving them a slimy green appearance. This thick layer of algae poses several problems for the plant. Firstly, it competes directly for the nutrients that we might be adding to the water with fertilizer. The algae are very efficient at absorbing these minerals, sometimes stealing them before the plant's roots have a chance. This makes it harder for our plant to get the food it desperately needs. The algae also have a significant impact on the oxygen levels in the water, but in a complex way. During the day, when there is light, the algae perform photosynthesis and actually produce oxygen, which can be beneficial for the roots. However, during the night, in the absence of light, the algae do the opposite. They consume oxygen through respiration, just like the plant's roots. In a jar with a thick growth of algae, the oxygen level in the water can drop dramatically overnight. This can create a dangerously low oxygen environment, suffocating the roots while the plant is in darkness. The algae, once a minor nuisance, have become a formidable competitor. To manage this, we could try to clean the jar. This involves carefully removing the plant, gently rinsing the algae from its roots, and scrubbing the inside of the jar clean before placing the plant back in fresh water. Another solution is to block the light from reaching the jar. We could wrap the jar in dark paper or cloth, simulating the dark environment of soil. This will slow down or stop the growth of the algae, as they cannot survive without light. This simple action can help to restore the balance in the jar, giving the plant's roots a better chance to breathe and absorb nutrients without competition. Despite these challenges, the plant continues to cling to life. The root system is now mature and has likely stopped expanding in size, as there is simply no more space. The growth is now focused on maintaining the existing structure and fighting off the negative effects of the environment. The roots may appear darker and less vigorous than they did in the early weeks, a sign of their age and the constant stress they are under. The plant's survival at this stage is a testament to its resilience, but it is clear that the glass jar is far from an ideal long-term home. It is a daily battle against suffocation, starvation, and competition. We have reached the 100-day mark. Our plant has completed its long and challenging journey in the glass jar. Looking at it now, we can see the full story of its struggle and survival. The jar is densely packed with a tangled web of roots, which are now mostly brownish in color, a sign of age and stress from light exposure and crowding. The vibrant white of their youth is a distant memory. The water, even with regular changes, may still have a slight tint from algae and the natural tannins released by the aging roots. The plant is, without a doubt, alive. But is it thriving? The answer is complex. The leaves on the top of the plant might still be green, and there might even be some new, small leaves, especially if we have been diligent with adding fertilizer. This shows that the plant has been able to draw enough water and nutrients through its confined root system to sustain life and even produce some growth. In this sense, the experiment is a success. The plant has survived for 100 days in an entirely artificial environment. It has demonstrated an incredible capacity for adaptation, growing a complex root system and enduring conditions of crowding, nutrient limitation, and competition from algae. However, the plant is not in a state of vigorous health. Compared to a similar plant grown in soil, it would likely be smaller and less robust. The root system, though extensive, is imprisoned by the glass. If we were to take the plant out of the jar, we would see a perfectly jar-shaped mass of roots. This system is inefficient and prone to problems like rot. The constant need for water changes and careful feeding shows that this is a high-maintenance existence. The plant is not self-sufficient. It is completely dependent on our constant care to counteract the deficiencies of its glass home. It is surviving, but not flourishing. So the verdict on this 100-day journey is one of qualified victory. Victory because life has persisted against the odds. The fundamental processes of root growth, water absorption, and adaptation have been beautifully demonstrated. But it is a qualified victory because the plant's health is compromised. The glass jar has proven to be an excellent short-term nursery and a wonderful window for observation, but it is not a suitable permanent home. The plant has reached the absolute limit of what is possible in such a confined and unnatural space. It has shown us its strength, but also its limits. Our 100-day journey watching a plant grow its roots in a glass jar has come to an end. We have answered our initial question. Yes, a plant can certainly survive and even grow for 100 days in just a jar of water. We witnessed the magical emergence of the first tiny roots, their rapid expansion into a complex network, and their ultimate struggle against the limitations of their glass world. This simple experiment has taught us so much about the hidden life of plants and their incredible resilience. It is a powerful reminder that the drive to live is one of the strongest forces in nature. The main lesson from the jar is a clear understanding of what roots need. We saw firsthand their need for space to grow, for oxygen to breathe, for nutrients to feed the plant, and for darkness to protect them from the stress of light and algae. Our glass jar provided water and a place to anchor, but it failed to provide the other necessities in the long term. The roots hitting the glass wall, the growth of algae, the yellowing leaves, and the risk of rot all pointed to the deficiencies of this artificial environment. The jar is an excellent teacher, but a poor home. This observation also highlights the miracle of soil. We often think of soil as just dirt, but our experiment shows that it is a perfect, life-sustaining system. Soil provides darkness, it holds water, but also contains pockets of air for roots to breathe. It is teeming with microorganisms that provide nutrients, and it offers almost limitless space for roots to expand. The struggles of our plant in the jar give us a new appreciation for the complex and vital role that healthy soil plays in supporting plant life on our planet. Our simple jar of water cannot compare to the richness of a handful of earth. In the end, our plant has been a wonderful guide. It has taken us on a slow, quiet, and profound journey into the fundamentals of botany. For anyone wishing to see nature's processes up close, growing a plant in a jar is a fantastic experience. It reveals the secret architecture of life that is normally hidden from our view. The plant has survived its 100 days, and now it deserves a better home. By carefully transferring it to a pot with good soil, we can give its crowded roots the space, darkness, and nutrients they have been craving. It can finally transition from merely surviving to truly thriving, a reward for its incredible endurance.